We present an integrated system for perception-driven autonomy with modular robots. This video showcases 3 hardware experiments that demonstrate the capabilities of our system. Experiment 1 takes place in the L-shaped office environment shown here. The robot has no knowledge of the environment before the experiment begins. Its task is to explore, find all objects of interest, and bring them to a designated drop-off zone. The following video was shot in one take using multiple cameras. The robot begins exploring the unknown environment. It quickly recognizes the blue square that marks the drop-off zone and remembers its location. The robot continuously performs SLAM, building up a 3D map of its environment as it drives. It selects waypoints for exploration using a next best view algorithm that maximizes information gain about the environment while also avoiding obstacles. The robot recognizes that the pink object is positioned in a narrow gap. Identifying this as a tunnel-type environment, it autonomously determines that a different configuration is needed to reach the object. The robot begins the reconfiguration sequence by lying down, so that modules that need to move will have their wheels in contact with the ground. A module detaches and uses its wheels to drive to the front of the car, where it spins in place to establish perfect alignment, then drives into place and attaches. Localization during reconfiguration is provided by a downward-facing RGB camera mounted high up on the sensor module. This is used to track April tag markers attached to the top of each reconfiguring module. The robot has successfully reconfigured into the proboscis configuration. Now it's able to drive into the tunnel and retrieve the object. Because the proboscis is unable to turn, the robot must reconfigure back into its original configuration in order to drive the object to the drop-off zone. It starts by dropping the object and backing up to make space to reconfigure. It then lies down again and begins the reconfiguration sequence. To make reconfiguration more reliable, we've developed techniques to assure strong connection between the modules. For example, when modules connect, the driving module overdrives its dock point to ensure the magnets make good contact. The robot picks up the pink object and begins navigating to the drop-off zone. As it drives, it spots another object, which will be its next target. When it thinks it's in the right place, it confirms that it can see the blue square and drops off the pink object. It then begins navigating to the other object it spotted. The environment characterization system recognizes that there's enough space for the robot to pick up the green object without reconfiguring. The robot drives in and latches to the green object using its magnets. The object becomes caught in a crack in the floor surface and is freed by a human operator. Note that this is a defect in the experimental setup, which is assumed to have a floor with no cracks. With the green object attached, the robot once again makes its way back to the drop-off zone. When it believes it's reached the drop-off zone, the robot once again performs a search for the blue square to ensure that it's in the right place. Once it finds it, the robot drops the object off, completing its mission. In the next 2 experiments, the robot will help researchers at the University of Pennsylvania mail a circuit board to collaborators at Cornell. First, the robot needs to place a circuit board in a mailbox. The robot begins in the scorpion configuration, holding the circuit board. After exploring, it identifies the mailbox, which is marked with a pink rectangle. It characterizes the environment in front of the mailbox as stairs and moves into position to reconfigure. By popping off its front 2 wheels, the scorpion transforms into the snake configuration, which is able to climb the stairs. At the top, it drops the circuit board into the mailbox and descends. At the bottom, the front wheels reattach to form the scorpion configuration again. Next, the robot needs to place a postage stamp on the box for shipping. The robot begins in the car configuration, holding the postage stamp on its right wheel. After navigating around an obstacle, it locates the pink square on the mailbox where it needs to place the postage stamp. It recognizes that the target is too high for the car configuration to reach, so it chooses to reconfigure into the proboscis. The proboscis reaches up and places the stamp on the box, completing the mission. Thank you for watching.